This is a tutorial on how to find the x-intercept of a function on the TI-84 Plus, and it has to do with exponential functions. However, you can do this with any sort of function. So first, I'm doing this on my computer desktop. So I'm not actually doing it on the calculator, but it still has the same capabilities. I'm going to go to y equals, and I'm going to, of course, make sure there's no equations or functions in here. If I need to, I can press clear and clear them out. Let me put in what we were working with in lesson 8.5, where Desmos did show the x-intercept, but the TI calculator did not. So the function we were working with was 3 raised to the x, and when I use the x in graphing or putting in functions, I'm going to use it's right next to alpha, and it has a couple other symbols with it. So x plus 5, close that parenthesis. This calculator is not an updated version where it puts the exponent in the exponent spot. And then I had to make sure to communicate to the calculator that the x and the 5 were a package deal. And then minus 6. Let me hit graph so we can just look at the function. And you can see it crosses the x-axis somewhere in between -3 and -4. If we wanted to find the y-intercept, so it's going to cross the y-axis way up here. If we wanted to find the y-intercept, we would actually look at the table. Okay, also to find the ordered pairs we're going to graph, we would look at the table. So let me go to second table, and you can see here's the y-intercept right away. Every single ordered pair on the y-axis has 0 in the x spot, some number in the y spot. And you can see why we can't see it on the graph, because it's huge. Okay? Now, when we're graphing, we had to make sure to place our x values around the h. So our input values for our table were around h. So h was -5 in this case. Okay, and for my table, I'm listed -7 through -3. So these would be the y values, or the output values I would use if I was graphing this on a paper. So let's go back to graph and let's talk about how do we find the x-intercept. I found the y-intercept at the ordered pair x is 0 and y happened to be 237. So finding this, I'm going to go to calculate, and it's in blue, so that means I have to hit second trace. Where the graphs, and it's all functions, where the functions cross the x-axis, it's called the function's zeros. So I'm going to go to option 2. So option 2, and I want to find the 0. So I'm going to hit enter. Now, if you see this left bound, okay, this baby, my cursor, we cannot see because it's all the way up at 237. So I want to go, I'm going to arrow to the left because I'm finding the left bound. And I want to go just to the left of where it crosses the x-axis. So I'm going to hit the left arrow, bring it on down. If you can see I'm still up at y is 41. We're getting lower, getting lower. Oh, you can see the cursor. Okay, I'm going to go just a little past where it crosses the x-axis. And I'm going to hit enter. Okay, now it's asking me for the right bound. So I'm going to arrow right and go just to the right of where it crosses the x-axis. And I can even go a little further. And I'm going to hit enter, and then I'm going to hit enter again, and boom, there you go. This is where, again, it's called the 0 of a function, The 0 of a function is the x-intercept. So it is at negative 3.36907, and then of course every single ordered pair on the x-axis has y being 0. This concludes this tutorial. If you have any questions, please ask your teacher. And practice, or if you want to use Desmos, because Desmos you can just hover over the x-axis where the graph crosses the x-axis and it pops up right away. But this is a good skill to know if you have a graphing calculator, so you know how to use your tool.